And let me share my screen, and let me start by sharing. This is actually the same screen that I started with on Friday. Because I had already uploaded a lot of word problems into the notes Friday, I'm going to recycle them and just tack today's notes on the bottom so that when you look in Blackboard, both Friday's notes and today's notes will be in the same document. 423 is under the bridge. Homework 5.2, I moved back to Wednesday, the 28th, instead of today, the 26th. Homework 5.8 is due the 30th. Everybody must do problem set 4 and problem set final. Guys, those problem sets are quiz grades. And so they must be done. They're not just in there for you to practice. They count as a grade. They count as a quiz grade. Test 4 will be available probably after class on Wednesday till Saturday. The final will probably be available from Monday to the end of the day, Wednesday. Again, just a reminder, if you have incomplete MyMathLab homework and you want to try to raise those grades, that must be done by the end of the day, Sunday the 2nd. And don't worry, I promise that no matter what MyLabs gives you as a grade in there, if I can see which assignments are late, and for every student, I look at the late assignments. And if there are any questions that you got correct, that they gave you less than half credit for, I will give you at least half credit. Before we start picking up from where we left off on Friday, does anybody want to look at any of the problems in any of the MyLab assignments? Or does anybody have questions on anything?
Should be good.
If not, the last person who's coming into class, and let me go to where we left off. We had defined all 6 trigonometric functions. We looked at those trig identities. We saw how if you know one function, you can find all of the remaining, or if you know 2 sides of a triangle, you can find all of the functions. We looked at how you can use a calculator to find a missing side or a missing angle. Picking up from there, I think the next place I want to go to is here, which are just a few more questions asking you to find. Here they ask you to find to the nearest whole number. And so in this one, we're asked to find little a. Again, in solving triangles, we're most likely to use our sine, cosine, tangent. And so don't be too proud to put a memory aid at the top of the page to help you identify which function you need, whether it's SOHCAHTOA or you're thinking through that Oscar had a heap of apples. And again, right now, we're only going to work in right triangles. So over here, in triangle ABC, right angle at C, I know angle A. So is everybody all right? Angle A is my angle of reference. It's the one that I know. I'm looking for little a. I know that this side is 250. What should I use? Sine, cosine, or tangent? If everybody all right from angle at A side, little a is my opposite leg. The side that we know is not the hypotenuse, so it must be my adjacent leg. And so opposite and adjacent tells me tangent. So we'll have that the tangent of our angle, 37 degrees, is equal to the opposite side, little a, over the adjacent side, 250. I'm going to put my tangent function over 1. Cross multiplying, I get A equals 250 times the tangent of 37 degrees. How does everybody feel about that work? From here, it's typing it into my calculator. Again, when I turn my calculator on, the first thing that I want to make sure is that my calculator is speaking degrees. And from last problem we did, it still is. So I'm going to just type in 250 times the tangent of 37. And I am getting to the nearest whole number that little a is 188. Is everybody all right with that one?
Yes.
Then I'm going to be quiet. I'm going to ask you folks to do this next one, 51. Similar yet different. How are you folks? Did anybody else get 182 inches?
Yes.
Next one, 53, is a little bit different. 53 is different because here we know angle A, that 16 would be the opposite, and that C is the hypotenuse. But what makes this one different is we're looking for the hypotenuse. And so sine is opposite over hypotenuse. So I get that the sine of 23 degrees, again, I'm in degree mode, is equal to the opposite, which is 16 over the hypotenuse, which is C. And what makes this difference is when I cross multiply, I get C times the sine of 23 degrees is equal to 16. And so to finish solving this one, I'd have to divide both sides by the sine of 23 degrees. And I get C is equal to 16, not multiplied by, but rather divided by the sine of 23 degrees. So again, I'm in degree mode. This time I'm going to take that 16 and divide it by the sine of 23. And I get C to the nearest whole number would be 41 meters. Is that one all right? Any questions? Not hearing any, then I'm going to stop, because this next one also would make use of division. And so I'm going to ask you folks to please here find little b. How are you folks doing? Did anybody else get B to be 24 yards? Did everybody else get B to be 24 yards?
Yes.
If so, then I'm playing hopscotch for a tiny bit through these pages. Next, I'd like to look at this page that I call solve a right triangle. And to solve a right triangle means that in a right triangle, if I know either two sides or one side and an acute angle, I should be able to find all of the remaining parts. All the remaining sides, all the remaining angles of the triangle. And again, if it's right, and this is only true if it's a right triangle, those of you who are advancing to Math 111 will find you will eventually be able to work with non-right triangles. But if it's a right triangle, the tools at my hand are the fact that the sum of the angles is 180 degrees. The Pythagorean theorem, and my trig functions. And again, don't be too proud to put a memory aid if you need one. And so let's go through and solve the right triangle. Let's find sides to the nearest hundredth. And let's find angles to the nearest tenth of a degree. Oh, there's no H at the beginning of 10th. What's going on here? And so first right triangle, we'll have this be A, B, C, right angle at C. For this one, we know that uppercase A is 52.6 degrees and lowercase c is 54. So here, this angle is 52.6 degrees. Little c would be this side is 54. So we have to find angle B, little a, and little b. If I know one of the acute angles, I think finding the other angle is usually the most straightforward. If I look at big B, we know that if the triangle adds to 180, we know that the measure of angle A plus the measure of angle B has to equal 90. Those acute angles have to be complements. So B would equal 90 minus A, or 90 minus 52.6 degrees, which is going to give us what? 37.4 degrees. Is everybody all right with that?
Yep.
Now, when I solve these, I usually like to use a method that goes back to not an answer that I got already, but rather to the information that I was given to make sure that I'm not making a careless mistake with what I had done previously. So here, I guess it doesn't really matter whether next we look for little a or little b. Does anybody have a preference? Not hearing any, I'm going to go in alphabetical order. So A is opposite and C is hypotenuse. And so opposite and hypotenuse tells me that I'll use sine. And so I'll get that the sine of 52.6 degrees is that opposite side, little a, over the hypotenuse 54. Cross multiplying, I'll get a equals 54 times the sine of 52.6 degrees. Again, make sure your calculator is in degrees. 54 times the sine of 52.6 gives me 42.89, rounding would be 42.90. To the nearest hundredth. Now, in order to find little b, let's do this one, I guess, in black. In order to find little b, I have a couple of choices. I can use trig, going back to the given angle and the given side. Or, being I have side A, and I'm pretty confident that that's correct, I could use the Pythagorean theorem. Which method would you folks rather look at? Not hearing any concerns. I'm going to go through and use the trig because it goes back to the given information. And I also think it's probably a little bit less work. That's the adjacent, and I know the hypotenuse. So that tells me I'm going to use cosine. And so I get the cosine of 52.6 degrees is little b over 54. And cross multiplying, I get b is 54 times the cosine of 52.6 degrees. Which gives me 32 point to the nearest hundredth 80. Is that one all right? So in that one, we knew side C. Let's look at another one. Let's look at one where instead we know, let's say just both the legs. So here I've got my right triangle, A, B, C. Let's say I know that little a is 15.3. Little b is 17.6. And so this one, I need to find both angles A and B and side little c. And again, in the order in which you do them, many times does not matter. It's a matter of personal preference. What would you folks find first? One of the angles or that missing side?
Angles.
Which angle would you find?
B.
B. All right, so then to find angle B, for angle B, if that's my angle of reference, we know the legs, the opposite and the adjacent. And so opposite and adjacent would be tangent. And so I would have that the tangent of B is 17.6 over 15.3. Wow. That's all the work. Because we're looking for the angle, remember to find the angle, you have to press that second button or shift button first. And make sure you're still in degrees. So for angle B, I'm going to type in second tan, opens parentheses, I'll fill those with 17.6 divided by 15.3. And I get that angle B is 48.9989 to the nearest tenth. That would be 49.0.
What did you press on the calculator?
I just press second because I'm looking for the angle. Tangent, because that's the function we're working with. And then to get that fraction, I'd type in the 17.6 divided by 15.3. Is everybody getting that same value?
Yes.
Any questions? If not, then, if we know angle B, let's use it to find angle A. Angle A, because they're the acute angles, they add up to 90. So it'll be 90 minus angle B. So when I take 90 minus 49, I get 41.0. And so then lastly, to find C, being I started with the two legs, I would probably use my Pythagorean theorem, a squared plus b squared equals c squared. So we'll have 15.3 squared plus 17.6 squared equals c squared. I'm not going to stop with in between numbers. I'm going to just, with my calculator, type the 15 point, well, clear out what was in there before. Type the 15.3 squared plus the 17.6 squared gives me 543.85 equals C squared. And then I'll go ahead and take the square root of that last answer. And I get C is 23.3205. So to the nearest hundredth, it would be 23.32. And does everybody see how if we know 3 parts of the triangle, one being the right angle, and one of the other 2 has to be a side, but beyond that, we can find all of the missing parts of the triangle. And so when they say solve the triangle, they're asking you to find all of the missing parts. If that's all right, then the rest of what we're going to look at today are applications, and those applications are going to be our word problems. In these that I downloaded from the virtual textbook, the diagram is drawn for you, but you should draw a diagram. And at this stage of the game, we always want to look only at right triangles. So if everybody's all right, I'm going to make this a little bit bigger. Can everybody read that question 77?
Yep.
It says a plane rises from a takeoff and flies at an angle of 10 degrees with a horizontal runway. When it's gained 500 feet, and here they show you that that's the altitude, find the distance that the plane has flown, which here they show you is this side C. From the angle we know, does everybody see that the 500 is the opposite and that C is the hypotenuse? So opposite and hypotenuse, I believe that's sine. And so here we get that the sine of our angle, 10 degrees, is equal to the opposite 500 over the hypotenuse C. Because the variable is in the denominator, that gives me a heads up that when I cross multiply, I'm going to have C times the sine of 10 is 500. And so when my variable is in the denominator of that ratio, that's the one that kind of tells me, oops, to get my final answer, I'm going to have to divide 500 divided by the sine of 10 degrees. And then after we get there, it's just a typing thing. 500 divided by the sine of 10. And again, before I hit equals, I always check to make sure that I'm in the right mode. In degree mode, to the nearest foot, I would get C is 2,879 feet. That one, all right. Next one then says a road is inclined at an angle of 5 degrees. After driving a distance of 500 feet along the road, so is everybody all right? That's my hypotenuse. I want to find the driver's increase in altitude. That would be this side over here, which is opposite the angle that I know. So taking that information, could everybody please tell me the change in altitude? I'll give you a couple of minutes.
That's 435.7.
Okay, but they asked to the nearest foot. So are you okay, all right, if I round that to 436?
Yeah.
Great. Next one involves a little bit of terminology that I want to make sure that you're familiar with. This one, let's change colors so we know when it's a different problem. It says a telephone pole is 60 feet high. So that's this height here. A guy wire. Do you guys know what a guy wire is? Do you ever see like a wire from the top of a pole to the ground to try to keep it from falling over? We're told that the guy wire has a length of 75 feet long and is attached from the ground to the top of the pole. We want to find the angle between the wire and the pole to the nearest degree. That would be this angle here. From this angle, does everybody see that the 75 is my hypotenuse? And now the 60. Would the 60 be my adjacent or my opposite?
Jason?
Beautiful. It's next to that angle, so it's adjacent. And so with adjacent and hypotenuse, which function is adjacent over hypotenuse?
Cosine?
Cosine. And so we'll have that the cosine of the angle we're looking for is the adjacent 60 over the hypotenuse 75. And that's our work. That's not typing. Again, it says to the nearest degree. So make sure your calculator is still in degrees. Because we're looking for the angle, remember, we've got to press that second first, second cosine. In the parentheses that open up, I'll put my fraction 60 divided by 75. And to the nearest degree, I'm getting that theta would be 37 degrees. Is everybody all right with that one? If so, I'm going to bump backwards to that first page that we skipped that deals with bearings. Bearings is sort of like, in some instances, almost like coordinates. It allows us to locate a position.
Yeah, I'm trying to remember. I wasn't doing like the last slide.
Oh, I'm sorry.
Yeah, I'm done.
Okay, when we look at bearings, it allows us to locate a position with an ordered triple. The first entry is always going to be north or south. The second entry is always going to be an angle that's measured from the vertical axis, which is the north-south axis. And then the third is always going to be east or west. What you have to remember is that the angle is always measured from that vertical axis, the north-south axis. And again, I have to apologize. I am going on an assumption that everybody's familiar with that little thing that you see in the corner of the map that goes north, south, east, and west. And so I'd like to look at these 4 questions on the side. Make it just a little bit bigger so I have a little bit more room for you folks. I guess I'll rewrite the N in. First, let's do 14, the bearings from O to, actually, no, you know what? I'm changing my mind. First, let's do 15, the bearings from O to C. When I go from O to C, does everybody see I'm not going up, but rather down? So the first would be the south. And when I go from O to C, I'm not going right, I'm going left. And so that would be to the west. And now for bearings, the angle is always the angle measured from the north-south line. So here it would be pretty straightforward, 80 degrees. So if I wanted to give somebody directions to go from O to C, I'd tell them to go south 80 degrees west. Instead, let's look at one of the ones we skipped. If I'm going from O to A, I think the directionals are pretty straightforward. Does everybody see that we're going north? And from that north, we're moving to the east. What makes this one different is that we do not know this angle. However, we're going on the assumption that our directionals are perpendicular. And so if this is a 75-degree angle, does everybody see that the angle that we want would be 90 minus 75 or 15 degrees? Is that one all right? So because this picture is getting pretty cluttered, I'm going to just scooch down to look at 16. There's more room to write. I kind of didn't leave a lot of room in there for 14. If I'm going from O to D, everybody all right? We're starting going south. From the south, we're heading towards the east. But again, in this one, the angle that we need is not given. So does everybody see to find that angle? I'd have to take 90 minus 35, which would give me 55 degrees. That all right? Sometimes we're given the angle we need, but remember that angle is always the angle that we turn to from either our north or south line. And if those are all right, the last 3 pages are just more examples, solving triangles. Some of them take a little bit more thought. Some of them are word problems, and some of them involve these directionals. Does everybody have all of this down?
Almost.
Did you say, I couldn't understand what you said. Did you say you were okay or that you needed a minute?
Yeah, I need a minute.
Okay.
Yeah, I'm through.
Okay. All right, so let's go to this page. These problems are some of the more involved ones, because as I look at this question number 30, I'm looking for the length of this segment, but this segment X is a side of the outer triangle, which is not right. And so I need to look for right triangles. And does everybody notice that here I have a little right triangle on the top? And I also have another right triangle on the bottom. I need to make use of my right triangles. And as I do that, when I look at this segment X, you see I can break it into 2 pieces. I'm going to call one Y, and I'm going to call the other one Z. And is it clear that X is equal to Y plus Z? Y is a side of the top triangle. In the top triangle, Y would be the opposite. And the 100 that I know would be the adjacent. And so that tells me I'll use tangent. And so I'll get that the tangent of 20 degrees is Y over 100. Or Y is 100 times the tangent of 20. Because I don't want to round off more than I have to, I'm going to stop there. Then, oh, I should have done that in red, not green. I'm getting my colors mixed up. Down here, Z, in that bottom triangle, is one of the legs, the opposite, and the 100 is the adjacent. So I'll also use tangent as opposite over adjacent. But here I'll have that the tangent of 8 degrees is Z over 100. And when I cross multiply, I'll get Z is equal to 100 times the tangent of 8 degrees. And again, I'm going to stop there, because I don't want to take the time to sit down, round, write down a number. and I'll be rounding twice. So now for my final answer, if x is y plus z, I'll type in that x is 100 times the tangent of 20 degrees. Be careful, you'll need to close a parentheses, plus 100 times the tangent of 8 degrees. You'll have to close the other parentheses that are open. Again, we want to make sure we're in degree. Then I'm going to go 100 times the tangent of 20. Again, I got to close that parentheses, plus 100 times the tangent of 8. And I get that x is to the nearest 100th, 50.45. And do you see what I mean in terms of we can't just look at that big outer triangle because it's not right. We have to make use of those right triangles. Let's look at this next one. This next one, what we're looking for is a side of that tiny little top triangle. Does everybody see that little sliver of a triangle on the top? It's definitely not right. So this time for our two right triangles, one will be this big outer triangle. And I'll say that that entire side is y. And in that big outer triangle, that's that one with a larger angle, 28 degrees. Y would be the opposite. 600 would be the adjacent. And so opposite and adjacent is tangent. So I get that the tangent of 28 degrees is y over 600. And I get that little y is 600 times the tangent of 28. But that's not what I want. I just want that top little piece. What I've got is way too long. So now I'm going to look for another right triangle in the picture. And this other right triangle, I don't know if you can tell, I'm trying to scribble it in with green. I'm going to call this side Z. And in that bottom triangle, I'll have that the tangent of 25 is Z over 600. And I get that Z is 600 times the tangent of 25. And I forgot to put my degrees symbol. I apologize. Now this time, can everybody see that the length of X would be the length of Y minus the length of Z? So X, I'll type in 600 tangent 28 minus 600 tangent 25. And I'm fine if you just type it in that way. If you use help me solve this, sometimes they factor that 600 out, which you could do, but you don't have to. So I'm going to just type in as it looks, 600 tangent 28. Don't forget to close those parentheses that are opened around the angle, minus 600 tangent 25. And here I get X is 39.24. Is that one all right? Any questions? Can I scooch it up or do I need to wait a minute? Everybody done with that one?
Yeah.
Next one's real similar. So I want to scoot down and look at this one here. Here, this would be also similar, but we're working with those other angles. Let me give you folks a minute. With this one, I'll let Y be the length of this long segment, part of the outer triangle. And I'll let Z be this piece here, which would be part of this green triangle. Did anybody else get 298.45?
Yeah, but I did like 1064 first.
Oh, that's okay. It's all right if you do them in the opposite order, just as long as you remember that you're taking the difference. And because it's length, always try to make sure that you subtract long minus short, because we're never going to get a negative length. Okay, great. Then this next one is probably the most challenging. Because as I look at this next one, the side that I know is not a side of either right triangle. I'm looking for a side that's common to both right triangles. It's the side that they share. What I don't know, though, is any complete side of a right triangle. And so in this instance, I'm going to go ahead and try to find all the missing angles. So if I look at this first red right triangle, to find this angle here, wouldn't I take 90 minus 40, and I get that that angle is 50 degrees. And then if I look in the big outside green triangle, I get this entire angle is 90 minus 20, or that whole thing is 70 degrees. Which is interesting. And realize with this combination of information, I also want to find this angle in here that I'm coloring blue. Is it clear that that blue angle would be 70 minus 50 or 20 degrees? Can everybody follow my reasoning so far?
Yeah.
And does anybody notice anything about that 20 degrees?
It's the same as.
Yeah, isn't it the same as the other one? And so doesn't this triangle, because these two angles are the same, doesn't that triangle have to have two sides that are the same? Isn't that isosceles? And so if this side is 400, this side would also be 400. And so now I can just focus on that little right triangle, and in the small right triangle, the one that I've tried to color red, the x is the opposite, the 400 is the hypotenuse, so that tells me I'll use sine. And the sine of my 40 degrees would be x over 400. Cross multiplying, I'll get x is 400 times the sine of 40 degrees. And I want to make sure I'm in degree mode. Then I'm going to go 400 times the sine of 40. And I get 257 to the nearest hundredth would be 0.12. Again, pay attention to those round off words. You're going to find this in the homework, in some iterations of the problem set, and in some iterations of the test. With Mr. Blitzer, if what he gives you is not a side of a right triangle, look at your angles, look for that isosceles triangle. So please notice with this one in advance, there's a lot of thinking, but there really isn't a lot of work. So those are problems that use two triangles. We're also going to have word problems that use two triangles. So here, and again, in the virtual textbook, and I believe in my labs, the diagrams are drawn for you, but let's look at this one. We've got a hot air balloon is rising vertically. So that hot air balloon is going straight up from a point on level ground. So if it's going straight up and it's level ground, we've got our right angle. And it's 125 feet away. The angle of elevation changes from 19.2 degrees to 13.7 degrees. How far to the nearest tenth of a foot does the balloon rise during this period? So this is what we're looking for, X. And again, notice X, what we're looking for is not a side of either right triangle, but we do know a side of each right triangle. So am I driving you crazy with the colors, or do the different colors help see things? So let's, looking at the big outside triangle, we'll call this side Y. And looking at the little bottom triangle, we'll call this side Z. And outside of the fact that it's a pretty picture, it's not a heck of a lot different than some of the ones that we did on the other page. And so I'm going to shut up and ask you folks to solve this one. How are you folks doing?
Good.
Did anybody else get an answer yet?
I go 34.
Okay, to the nearest, oh, it says to the nearest tenth of a foot. So be careful rounding to the nearest tenth. Did you get 33.7,
Yeah,
which would round to 34?
yeah.
Great. Gonna skip 50 for a minute because it's similar. And I want to look at 58. It says, whoops, a ship leaves port with a bearing of south 40 degrees west. After traveling 7 miles, the ship turns 90 degrees and travels on a bearing of north 50 degrees west for 11 miles. At that time, what is the bearing of the ship from the port? Oh boy, lots going on here. I'm going to let this be my port. And so I'm going to draw my directional. North, south, east, and west. I'm leaving the port going south 40 degrees west. So I'm going south and I'm turning 40 degrees to the west. And I'm doing that for a distance of 11 miles. Everybody all right so far? Then, once I'm 11 miles out, I turn 90 degrees. And how am I going to turn that 90 degrees? They're telling me I'm turning that 90 degrees. So from this point, I'm going north 50 degrees west, north 50 degrees west. And they let me know that that makes this a right angle. And I'm going to do that for, oh, I have to apologize. I got my numbers mixed up. It's because I don't have my glasses on. I have to apologize. This first one was 7 miles. And this second one, I apologize, is the one that's 11 miles. And now what I want to know is what's this bearing? Well, again, I'm not real accurate on my scale in terms of my 11 miles distance versus my 7 miles distance. And I didn't use a protractor to measure my angles. But right now it looks like my bearing might be northwest, but again, I'm not sure. Does it make sense that in order to reach that decision, I might want to find the measure of this angle in here, theta? And so theta, let's see, we know the opposite and the adjacent. So that tells me I'll use the tangent of theta is opposite over adjacent. So to find the angle theta, I'll go second tan 11 over 7. Gives me that theta is 57.52 degrees. So yep, this is 40 and I'm going 57.52. I am going northwest. But the angle that I now need to know is this angle here. And to find this angle here, I could say that the sum of these three is 180. Or I could find how much further I am from the 90-degree angle and subtract that from 90. I'm going to say that that angle is 180 minus 40 minus that 57.52. And so that would give me 84.48 degrees. Everybody all right with that? What if I added another part to this question that asks, this is where my boat is, right? How far is the boat from the port? Because we have a right triangle and we know the legs, we're looking for the hypotenuse. We can use our Pythagorean theorem. And we'll get the square root of 137. Or 11.7 miles. And do you see how we used our bearings to find that boat's location?
Where'd you get the 4 from?
I'm sorry, Michael, what?
Where'd you get the 4 from? I thought it was 7.
Oh, it is 7. I have no idea where I got that 4 from. That 16 should be a 49. I think I got that 4 from the fact that I took my glasses off, and with my vision, that should never happen. Did you do it with the right numbers?
Yeah, that's what I was confused at. I'm like, why
So
did I-
that's the square root of 170?
Yeah.
And so that's actually 13.0 miles. Thank you very much for correcting me. Hey, guess what? I think I might have gone over time-wise. These are the types of problems that we looked at today that you'll find in that homework 5.8, but this is the end of the new content. And so on Wednesday,